Okay, guys, so that is question number 2. Then question number 3, we're being told that a ball is thrown vertically upwards, okay, with a velocity of v from the edge of the roof that is 40 meters tall. The ball takes 1.53 seconds to reach the maximum. Okay, so might is 1.53 seconds. Ignore that. Can we define free fall? So free fall is just the motion of an object under the influence. Okay, under the influence of gravity, or you can just say gravitational force. Then 3.2, calculate the magnitude of the initial velocity v. So it takes 1.5 to reach the maximum. So we know that at maximum height, okay, I'll say height max, the final velocity must be a 0. So I can use the first equation of motion. V final is equal to V initial plus the A delta T. So my V final, we say is a 0. V initial is what I want, but we know that G is going to be 9.8 multiplied by 1.53. Now, the direction that you use for the G will matter. Let me take downward to be positive, and since we're going up, I'm just going to use negative, okay? So then I have 0 is equal to V initial minus 9.8 times 1.53. That gives me 14.99. Then I'll move it that side. So my V initial is 14.99 meters per second, which is more or less the same as 15. I don't know. I'll just leave it as that. It's fine. Then 3.2.2, calculate the maximum height that is reached. So we can still use the effects that we have, that the delta T is 1.53. The V final is 0, and then we're looking for the displacement. So you can use, we can choose to use the V initial. Either way, we have to use the V initial, because if I look at my displacements, V initial multiplied by time plus a half G delta T squared. Either way, there is V initial. If I use V final squared, it's going to be V initial squared plus 2 multiplied by G delta X or delta Y. So either way, so let me use this second and say that my delta Y is going to be the V initial. My V initial is 14.99 multiplied by the 1.53. Now I'm going to use minus a half times 9.8 multiplied by 1.53 squared. Now you can use a plus, yeah, but then the value of the sign next to the G should be a negative. That's if you're using the same direction as my source. So 14.99, okay, times 1.53 minus a half times 9.8 times 1.53 squared. I'm getting 11, something. 11.47 meters. So that is the height, or the maximum height, 11.47. All right, so that is 3.2.2. Then 3.3, can we take the edge of the roof as the reference point? We need to determine the position of the ball relative to the edge of the roof after 4 seconds. So from this point of projection, if this is our zero line, that's what it means to take it as a reference point. So after how long, or after 4 seconds, what will be the position of the ball? So I can still use the same formula of the delta y, but where there's time, I can just use the 4 seconds. Is that okay with people? Good. So we said we're using the same formula. So delta y is equal to V initial times delta t plus a half g delta t squared. Okay, my delta y. So let me just correct this, guys. It's supposed to be A. Let me even correct this. It's supposed to be A because A is the formula. We don't have G in the formula. So let's write the formula down. You get that mark. And then the substitution, then you replace A with a G. Okay, so V initial, we said it's 14,99. Now we're looking at 4 seconds plus a half. That's going to be negative 9,8 times 4 squared. Okay, if I punch that into my calculator, saying times 4 plus 0,5 multiplied by negative 9,8 multiplied by 4 squared. That gives us negative 18,44. Okay, so one thing we need to know is as long as an object moves from the point of projection, reaches maximum and comes back to the point of projection, we call that a displacement to be 0. Then afterwards, this 18,44 is just the distance below the building or below the reference point. So we interpret the negative sign by telling us the position is 18,44 meters downwards, or we can say below the top of the building, below the edge of projection. Edge of projection. All right, then 3.4. We'll end of the answers in 3.2 and 3.3. Change if the height of the building is now 30 meters. Choose a yes or a no. Now, looking at what we've been working with in 3.2 and 3.3, I mean, we've not applied this height in any way. Okay. So the fact that this 40 is not in any of our calculations and it does not have an effect on the maximum height that the ball must reach, I mean, there's not going to be a change. Because remember, we are ignoring air resistance. I mean, if air resistance was there, then we would say that, yes, it might have a change. But since air resistance being excluded, our answer is going to be a big no. Okay, it's a no. And what is the reason? It's saying that motion of the ball is only independent. Should I say independent or dependent? Let's use dependent. Dependent on initial velocity. It does not depend on the point of projection or what. Okay. Then someone says, will that give you 3 marks? Yes, to give us 3 marks. Remember, we took a stand to say it's a no. And then our explanation can give us the other 2 marks. All right, then question.